Welcome to Pavinars. My name is Andrew Bram, and today we're very briefly going to talk about NCHRP Report 919, titled Field Verification of Proposed Changes to the AASHTO R30 Procedures for Laboratory Conditioning of Asphalt Mixtures. There were actually two phases to this research. The first phase was under NCHRP Report 815, titled Short-Term Laboratory Conditioning of Asphalt Mixtures. And during this project, they proposed a short-term aging protocol, which is where you have a loose mix and you age it for 2 hours. And if you're aging a hot mix asphalt mixture, you age it at 275 degrees Fahrenheit. If it's a warm mix asphalt, you age it at 240 degrees Fahrenheit, with the associated Celsius temperatures shown. For the long-term proposed aging protocol, you short-term age the material, then you compact it, then you age it 5 days at 185 degrees Fahrenheit or 2 weeks at 140 degrees Fahrenheit. So the purpose of phase 2, which is this research, was to validate the phase 1 research in the field. And so they chose 9 field sites in 8 states scattered across the United States, as seen on the right. And the different factors they looked at were warm mix asphalt technologies, plant mixing temperatures, the mixing plant type, the amount of absorption of the base aggregate, the climate, the RAP and the RAS content, reclaimed asphalt pavement and recycled asphalt shingle content, and then also the asphalt binder source. They also looked at the 2 aging models, which they had split into a north and a south region. So the 5 stars in the northern portion of the map were in the north region and the 4 in the south region, to account for the less aging that occurred in the colder northern climates in the United States. So an analysis of the factors, they found that for asphalt absorption, the theory was that the effective asphalt, or the asphalt that's coating the aggregate, was actually a little different than the base asphalt because they thought that the lighter ends would go deeper into the aggregate, which would leave the heavier and more brittle asphalt binder components on the surface. However, they did find that the volumetric mix design may have overcompensated for these highly absorptive aggregates, so they didn't see that trend. They found that the asphalt source was the second most impactful factor after the RAP and the RAS content. They found that more RAP or RAS created a higher stiffness mixture, so more reclaimed asphalt pavement or recycled asphalt shingles created a higher stiffness of the mixtures, and this was the greatest effect in the study. They found that for warm mix technology, warm mix asphalt technology in general, WMA does not age as much as hot mix asphalt or HMA, and has better aging behavior up to 5 years. And finally, they found that changing the production temperature by as much as 30 degrees Fahrenheit had no significant effect. And what they did is that they took cores on the 9 sites, that's the graph on the right, and they took cores on various cumulative degree days. And in general, they found that the CT index which is found from the ideal CT test, decreased as the cumulative degree days, or CDD, increased. However, they said that more research was needed, which I always appreciate. If you're interested in learning more, the link to the report is down below in the comments section, and you can download it for free, or you can simply search the title of the NCHR report, which is another way to find the document free of charge for download.